We've looked at the difference between a recursive and an explicit formula, and it's important to note that there may be, and usually is, more than one formula for any given sequence. So you'll often find that what you're asked to find is a possible formula for the general nth term of a sequence. So let's look at a couple examples here. There is no set way to always find the formula, so it's important to be willing to do some trial and error. Let's begin with example 3, part A here, where we have -3, 9, -27, 81, and -243. Observing and looking for patterns will help you determine these formulas for a sequence. I like to begin by labeling what term they are. So the first term is -3, second, third, fourth, fifth. And that might help you associate in terms of a pattern. If that doesn't help, it's often helpful to factor. So if you notice here, this is 3 to the first, 3 squared, 3 to the third, 3 to the fourth, and so on, except every other one has a negative. The nth term of a sequence is 3 to that third power, multiplied by -1 if it's odd. So a way we can associate that or write that formula is a sub n is -1 to the n, 3 to the n, or it can be written as -3 to the n. We could have also used a recursive formula, because if you notice that if a sub 1 is -3, a sub n is -3 times the previous term for those n greater than or equal to 2. If we look at part B here, we can follow a similar process. Our first term is 1. Our second term is 3. Third is 6. Fourth is 10. And fifth is 15. We don't really have anything that we can factor here, but we can rewrite things in terms of each other. So for example, we have 1, and then here this is 1 plus 2. This is 3 plus 3, which notice is the previous term. This is 6 plus 4. This is 10 plus 5. So notice each time we're taking the previous term, which is a sub n minus 1, and we're adding the nth value. So our a sub n is a sub n minus 1 plus n, again for that n greater than or equal to 2.